record. Be a good test. All right, so last class we talked about sequences, and this class we're just going to do an overview again of series so that if you missed doing some of those virtual assignments, you could go back and do them. But we talked about this yesterday. Big idea. How is a series different from a sequence? This is 364 in your new packet. Who can tell me how a series is different from a sequence? What's different? Come on, you know this. Look down below at example 1. How is the sequence and the series different from each other? The big thing. What symbol? The what? You're adding, right? A series is you're adding terms, and a sequence is you're just listing terms. So adding terms versus just listing the terms, but the actual formula is the same. A sub n equals whatever. So here's an example of an arithmetic sequence, 6, 10, 14, and 18. It's going up by how much each time? 4. So if I asked you, what is a sub 4, what would you say? A sub 4 is just 18 in this sequence. So the notation A sub 4 just means the term number 4. Term 1, term 2, term 3, term 4 is 18. I don't even have a formula right now. All I have is just the list of the sequence. And go ... it goes on forever. This is the same pattern, just written as a series. 6 plus 10 plus 14 plus 18 ... This time it's asking you capital S sub 4, which means the series. So what you need to do is actually add together all 4 of those terms. Term 1 plus term 2 plus term 3 plus term 4. So what is S sub 4 for this series? What is it? 48. So it's really important that you're focusing on the notation. A sub 4, what is term 4? S sub 4, what is the sum of the first 4 terms of that series? And it says, could you find the infinite sum? So it goes ... Could you find the sum of all these numbers forever and ever, and why or why not? Could you? What would be the sum? You couldn't, there's too many numbers, and it diverges. The numbers are getting bigger and bigger and bigger. So no, because the series diverges. So I can't, it never ends, right? There's too many numbers that never end, and they get bigger and bigger and bigger to infinity. It diverges to infinity, right? You could always go one more term, and then you could always go one more term past that. So that's arithmetic. Here's another example of an arithmetic sequence and series. 60, then 55, then 50. So for this one, I said, what is a sub n? That means, can you write a formula for any term? So how would I write the formula for this arithmetic sequence? So from yesterday, what's the formula for an arithmetic sequence? 60. So what are you starting with? And then your difference this time is you're going down by 5, n minus 1 times. So up here, they just wanted you to find the term. Here, a sub n means give me the formula. And then now I'm going to look at it as a series. So it says, what is S sub 20? Find it 2 different ways. So I don't want to just add it up forever on my calculator. I want to use that sigma notation shortcut, and then I want to show you that formula for the sum of a series. I'm going to the 20th term. So to write that using sigma, you write, I need to write it a little bit bigger. So what is the sum? N goes from 1 to 20 of 60 minus 5 times n minus 1. So that's what it means to use sigma notation on your calculator, and it's under the math key, and you scroll all the way down to 0. Summation. So if you haven't tried these on your calculator yet, you need to hit the math key, arrow down to choice 0, summation, and type this in. Where it says n, you're going to use the x variable key. And I'll type it in on my calculator. Oops. All right. So I'm going to go to the math key, arrow down to summation. So now I have all of the empty spaces to fill in. The x variable key is right here next to the word alpha. So you're going to hit x in place of n. X goes from 1 up to 20. So 1 to 20, oops. So 1 to 20 get typed in here, and then you type your formula in as 60 minus 5 parentheses x minus 1 close parentheses. This parenthesis should always be on the far outside because that goes with the summation. All your stuff should be in between their two parentheses. So if you want to add your own parentheses, you add it inside their parentheses. All right, so then you hit enter to figure out what the summation is, and the calculator's adding together. It's plugging in term 1, term 2, term 3, term 4, and adding them all together. So this tells me it's 250. Did everyone successfully type it into their calculator and get 250? If not, this is an important thing to do on your calculator, so we need to make sure that we're getting the right answer. That's using the summation on your calculator. Option number 2 is to use this formula, and it's dealing with the number of pairs of numbers. So it's n divided by 2 times a1, so the first term, plus a sub n. So in our case, we need to figure out a sub 20, the first term and the last term. N divided by 2 is going to be 20 divided by 2, and we know the first term is 60. We need to figure out a sub 20 for our function. So a sub 20, we're going to plug that in, just that term, into our formula over here. So I do 60, basically minus 5 times 19, right? I'm subtracting 5 19 times to get to the 20th term. 60 minus 5 times 19 is negative 35. So negative 35 would be the last term of this, the 20th term of the sequence. So you take 20 divided by 2, because you're going to pair up the first and the last term. And then you've got 60 plus negative 35. 10 times 60 minus 35 should come out to 250. Does it? Yes. And I can't remember if we talked about yesterday why that works, but let's just talk about it on a smaller scale. So what if you had, I don't know, the numbers 4, 9, going up by 5, 14, and 19, right? So I want to add those 4 terms together. If you pair up the first and the last term, what's that add up to? 23. If you add up to the next term and the next term, it adds up to 23. An arithmetic sequence, when you add the first and the last, or the second and the second to last, you're always going to get the same answer. Like if you did 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you keep pairing these up, these pairs will always add up to 11. So you'd have 5 pairs of 11 is 55. So you don't have to add 1 plus 2 plus 3 plus 4 plus 5 up to 10. You find the sum of the first and the last term and multiply by the number of pairs. So if there's 10 numbers, there's 5 pairs. If there's only 5 numbers, there's 2.5 pairs. So it's okay to have an odd number of pairs because you've got one term that doesn't get paired up with anyone. So that's why this is working. We had 10 pairs of numbers. That was the first term and the last term added together, and we multiplied by 10 and got 250. Okay, so on the front page, I talked about arithmetic, and on the back page, I'm talking about geometric. So I'd like you to try example 3 on your own for a couple minutes. I've given you the sequence. You're going to generate the formula, the 10th term, and then I'd like you to find S sub 51, trying the 2 different ways. So I can walk around and help you, but to be able to do arithmetic, you have to be able to kind of do all of these like 6 things. So I'm going to pause for a minute. All right. So I think we all got the same sequence. It was the 5 plus 7 n minus 1 times, which makes a sub 10 68. And then whether you do summation or the formula, you should have gotten 9180. So I think most of you at least did it one way. To me, it makes sense. If you've got the calculator, you kind of need to use a calculator on this one anyway. So the formula doesn't really save you time. I'd rather just type it into the calculator, but there are times when you might not be able to use the calculator, or I just want you to explain how to use this formula. But to me, sometimes I do it both ways just to verify my work is correct or my formula is correct. It's a nice way of checking your work that you've got the correct sum or that you typed it in correctly. So those are arithmetic ideas. Finding a term, finding the sequence equation, basically, and then doing the summation the 2 different ways. Those same big ideas we need to be able to do with geometric. All right? What? Geometric, see here, all right, geometric is when you have to multiply by something each time. So this one is asking you what would a sub 4 be for this sequence. So if you multiply it again by 10, you would have what for a sub 4? It's just adding a 0 each time, right? Multiplying by 10, so it'd be 4,000. Not asking you to write a formula, just this is kind of step 1. Can you finish the pattern? And then can you just understand this notation? I want you to add these 4 terms together. So I would just add them together on your calculator. 4 plus 40 plus 400 plus 4,000 comes out to a bunch of 4s. 4 in every place. 4, 4, 4, 4. Right? Because you have 4 that are singles, 4 that are tens, 4 that are hundreds, 4 that are thousands. That's like, what is a geometric sequence? Generate a term. And then the next part, you take it a level up. Now you've got to generate the 4th term, but I also want you to generate the formula. So the pattern this time is it's being multiplied by a half each time. So if they're asking you for a sub 4, that's just 4. And a sub n, we have to know how to write a geometric formula. It again starts with the first term. So the first term this time is 32. Then instead of like adding or subtracting, you are multiplying by the ratio. So if it's division, you want to represent that as multiplying by a fraction to the n minus 1 power. So the starting term times the ratio, multiplication is expressed as an exponent. So a half times a half times a half times a half. Same geometric series over here. This time they want you to just add up those 4 terms. So what is s sub 4? 32 plus 16 plus 8 plus 4. So that just comes out to 60 when I add those 4 numbers together. So there's a lot of information packed into this. Just reading, the notation is one step. Being able to generate a formula is kind of the second tier. And then kind of the third tier, the pre-calculus tier, is finding sums. So what is the infinite sum of this series? And why can I find it? So why am I allowed to add together all of these terms forever? But on the front page, I could not add all these terms forever because it was getting bigger and bigger and bigger, right? It was diverging. This is considered converging. Every time you add a number, you're adding less and less and less, right? You're adding 2, adding 1, adding a half, adding fractions. So the infinite sum, finding it 2 ways, I want to show you how to use your calculator in case you forget the formula. So I can't actually type in the number infinity, but you could type in a big number. So 32 times a half raised to the n minus 1. If you want to find the infinite sum, you cannot type in infinity, but you could type in a big number like 50 or 100. 50 is probably enough. Let's see if 50 works. X goes from 1 to 50 of 32 times a half raised to the n minus 1. If you want to practice typing this one in, just to make sure that you know how to type it in with parentheses or decimals or exponents. So even when I went to 50 terms, the calculator already converged to the integer 64. So I probably could have even done less than 50 terms because it goes to like 63.999. Let's try 30 terms instead. 63.9999994. So 30 terms wasn't quite enough for the calculator to catch up to it, but 50 was. Oh, I do somewhere. Oh, that? Computer charger, right? Yeah. Sure. All right, so why is it 64? Well, this formula is the converging formula for the geometric series. You take your first term, which was 32, and you divide by 1 minus your ratio. 1 minus a half is a half. So it's actually 32 divided by a half. When you divide by a fraction, you multiply by the reciprocal. So see how 32 divided by a half would actually be 64? It's like asking you how many half dollars are there in $10? There's 20 half dollars in $10. So there's it converges to 64. So that's the infinite sum two different ways. Use a big value on your calculator or use the formula. All right, I'd like you to try example 6. Try that one on your own for a minute. So 236.25 was term 4. The formula would be 70 times 1.5 to the n minus 1 power. S sub 4, you're just adding up the 4 terms. And you can't find the infinite sum because it diverges. It's getting bigger and bigger and bigger each time. The fraction has to be less than 1 so that it gets smaller and smaller and smaller each time. So I just said if it's converging, you're getting closer to adding 0 each time, so the sum will approach a certain number. Whereas if it diverges, it's just getting bigger to infinity or negative infinity. So, I mean, you don't have to write down all my words, but that's kind of, it is important to know if it's going to converge or diverge. Will it get closer to a certain number, or will it go blow up bigger to infinity or smaller to negative infinity? Because then you can't add them all up.